This question was asked in the GATE Physics paper 2015. This is a numerical answer type question having 2 marks. The topic of the question is quantum mechanics. The question is, let the Hamiltonian for two spin-half particles of equal masses small m, momenta p1 vector and p2 vector, and positions r1 vector and r2 vector be h equals to 1 by 2m times p1 square plus 1 by 2m p2 square plus half of m omega square times r1 square plus r2 square plus k sigma 1 dot sigma 2, where sigma 1 vector and sigma 2 vector denote the corresponding Pauli matrices. H cut omega equals to 0.1 electron volt and k equals to 0.2 electron volt. If the ground state has net spin 0, then the energy in electron volt is, so we have to find the ground state energy for this given Hamiltonian of this system. Let us see how to solve this problem. So, according to the question, the given Hamiltonian for two spin-half particle system is p1 square by 2m plus p2 square by 2m plus half m omega square times r1 square plus r2 square plus k sigma 1 vector dot sigma 2 vector. Here sigma 1 vector and sigma 2 vector denotes the corresponding Pauli matrices. So, in the Hamiltonian, the first three terms, that is p1 square by 2m plus p2 square by 2m plus half m omega square times r1 square plus r2 square, these three terms is basically denoting the two spin-half particles in three-dimension quantum harmonic oscillator potential. So for this part of Hamiltonian, we know what will be the energy eigenvalue. The only thing we are concerned about, that is k times sigma 1 dot sigma 2 vector. So what will be the energy eigenvalue for this term? So let us evaluate this. For this, what we will do, we have total moment, total spin, that is sigma vector equals to sigma 1 vector plus sigma 2 vector. Here sigma 1 vector is the spin of first spin-half particle and sigma 2 vector is the spin for second spin-half particle. So we'll take the dot product on the both side with sigma. So we'll get sigma dot sigma equals to sigma 1 plus sigma 2 whole square. So sigma square equals to sigma 1 square plus sigma 2 square plus 2 times sigma 1 vector dot sigma 2 vector. So from here we can get sigma 1 vector dot sigma 2 vector equals to half of sigma square minus sigma 1 square minus sigma 2 square. So we have the Hamiltonian p1 square by 2m plus half m omega square r1 square. So this is the three-dimensional simple harmonic oscillator potential for the first spin-up particle, and similarly for the second spin-up particle we will have this three-dimensional quantum harmonic oscillator potential, that is p2 square by 2m plus half m omega square r2 square, and the spin-spin coupling term we have rearranged it as k by 2 times sigma square minus sigma 1 square minus sigma 2 square. So we are denoting this term as H1 and this two term as H2. So H1 and H2 are basically Hamiltonian for the three-dimensional quantum harmonic oscillators, and the last term, that is spin-spin coupling term, that can be written as k by 2 times 2 by h cut whole square times s square minus s1 square minus s2 square, because we can relate this spin operator and the Pauli matrices by this relation, s vector equals to h cut by 2 times sigma vector. So we have the Hamiltonian, that is h1 plus h2 plus 2k by h cut square times s square minus s1 square minus s2 square. So here H1 and H2 are Hamiltonian of a spin-half particles in three-dimensional quantum harmonic oscillator. So the energy eigenvalue will be E equals to N1 plus 3 by 2 times h cut omega plus N2 plus 3 by 2 times h cut omega plus 2k times s into s plus 1 minus s1 into s1 plus 1 minus s2 into S2 plus 1. So here actually the eigenvalue for S square will be S into S plus 1 times h cut square. So for that h cut square, that will be cancelled out with this h cut square in the denominator, and that's why we are getting this term. And for the first two terms in this energy eigenvalue is basically the energy for the three-dimensional quantum harmonic oscillator. Here N1 consists of three principal quantum numbers, that is nx plus ny plus nz. So we are denoting for the first particle, that is nx1 plus ny1 plus nz1, as N1, and similarly for the second particle, that is N2. Now in the ground state, the three-dimensional quantum harmonic oscillator will have the nx equals to 0, ny equals to 0, and nz equals to 0, and n1 and n2 are the summation of the x, y, z components, so both will be 0. And according to the quotient, total spin is 0 at the ground state. But S1 and S2 is equals to half because they are spin half particle. So we'll put these values in the ground state energy eigenvalue. So we'll get 3 by 2 times h cut omega plus 3 by 2 times h cut omega plus 2k times 0, because total spin is 0 at the ground state, and for S1 equals to half and S2 equals to half, we will get minus half times half plus 1 minus half times half plus 1. So from this we will get ground state energy eigenvalue, that will be 3h cut omega minus 3k. Now it is given that h cut omega equals to 0.1 electron volt and k equals to 0.2 electron volt according to the question. So we'll put these values in the ground state energy eigenvalue. So we'll get ground state energy eigenvalue EGS equals to 3 times 0.1 minus 3 times 0.2 electron volt. So effectively we will get the final answer, that is energy eigenvalue of the system is minus 0.3 electron volt. So for this given Hamiltonian, at the ground state energy will be minus 0.3 electron volt.